Okay, so we're starting chapter 24 today, and chapter 24 is all about comparing means. At this point, these chapters, these few last ones, they won't take us that long because we've already done confidence intervals and hypothesis tests a handful of times with proportions and already one mean, so we should be getting the gist of what's happening. All right, so if we're just talking about confidence intervals in general, okay, what are the steps to a confidence interval? Well, the first thing to do is check your conditions. We'll talk more about the conditions for a two-sample test in a second, but they're going to be generally the same as a one-sample test for means. So you need to have independence. Remember, you're comparing groups, so we're going to have a special condition for that. You have to have randomness of some sort. You can still talk about 10%, but we'll talk about that too. That one kind of gets awkward, and it probably did as you when working in one samples. And then we have to talk about sample size, and we talked about the data being nearly normal, and we'll talk more about that today. All right, so we still have the same conditions. Then we need to make our statement. The entire purpose of this statement is to name the test or the interval, depending what you're doing. Let's get to intervals today, but we're going to name the test and the interval. That's why I keep asking you to write that sentence. Because the conditions are met, we can perform A or construct A. This is why on the AP exam, on all of those free response questions that ask you to either do an interval or do a test, it just asks you to perform that. So you do write it all out. Well, in the rubric somewhere, I guarantee it says for partial credit or of a point or for a point, something in there it says. Name the test or interval by name or formula. So you need to have that. It's important. It's not just something I keep telling you to do for fun. So we're going to name the test or the interval. After we do that, we do the mechanics. For confidence intervals, we keep doing the same thing. Now, on your formula sheet for the AP test, it says for a confidence interval, you always have a statistic, plus or minus, a critical value. Now we've seen two of those. We've seen Z star for proportions, and now we've seen T star for means. And you multiply that by the standard error, the standard deviation, depending on what information you have. Okay? It says that for you. You just know what those things are. So, remember, keep in mind what a statistic is. And then you have to, after you get the interval, you have to write a conclusion statement. I am 95% confident that. I am 90% confident that. I am blanky blank percent confident that. Okay? So you have to keep making those same steps for the confidence interval. Okay? Now, this will be very similar to a one sample T interval, but since we're comparing means, we'll have two samples. So if you think about your statistic that you're going to need up here, that'll be compared to a parameter. And I keep making a big deal about this because we need to know the difference. But so for one sample mean, we have a statistic of X bar or Y bar and a parameter of mu. When we're comparing means, we compare them just like proportions. So what did we do when we compared proportions? Like in our null hypothesis, or when we did a confidence interval, what was our statistic for proportion? Well, it was subtraction. So same thing here, we'll have X bar 1 minus X bar 2, or mu 1 minus mu 2. Okay? So, similar ideas, so it shouldn't be too bad. Okay. So, our conditions for a interval today. Independence. So each group must be drawn independently. That's not new. Remember that was independent groups when we talked about proportions. That is still a thing. Okay? Then to back up your independence assumption, we talk about randomization. Were the data collected randomly? Is it representative? Yada, yada. And then 10%, we don't usually check this condition. because you end up having these small samples and they sound weird. Okay? So if you only sample 20 things, well, or you 20 samples, then 20 is less than 10% of all. Well, sure it is. So it kind of sounds weird most of the time. And then you have nearly normal. Now, when you're checking the nearly normal condition, you should check this for both groups. Okay? Both being the key word. That means you will have two different data displays to look at. Hopefully. Okay? You should be looking at a histogram or a normal probability plot. We can talk about what those look like in a second if we need to. I'm sorry. I can't write today. Okay? A histogram should be roughly unimodal and symmetric if it's going to be nearly normal. And a normal probability plot should be relatively straight because you're looking at a scatter plot, essentially. So you have to say those things. You can't just be like, oh, it's nearly normal. You need to say a histogram of the data shows that. A normal probability plot of the data shows that. The data is roughly unimodal and symmetric. It's reasonably straight. Something to that effect for both the groups. You can't just say, it's nearly normal. Also be careful about saying the sample size is large enough. We generally can only get away with that if the sample size is in the 40s or the 50s. So don't just say, the sample size is large enough. Not good enough. Okay? So we've checked our conditions. No big deal. Now, if you want to compare two groups, this is just a reminder, but you can use box plots if you're going to go ahead and look at them. All right, that's just a review thing from back in the first unit. If I want to compare two groups, a box plot's nice because I can compare the medians, I can compare the spread, I can see the whiskers and see if their data is way more spread apart than the other, if the boxes are way more spread apart than the other. Right? So box plots are helpful if you're trying to actually make some decisions about comparing the two. Okay. For chapter 24, difference in two means. We have a two sample t interval. Okay? So that should not be surprising. This is the same thing we've had all year long for confidence intervals. All semester long, I should say. You always have, again, the statistic plus or minus the critical value times the standard error every time. So in this case, our statistic is x bar 1 minus x bar 2, or y bar 1 minus y bar 2 as our book uses. And then it says plus or minus the margin of error. Well, we know that the margin of error is the critical value times the standard error. So in this case, our critical value is t star, standard error. We have a formula for that. Okay? So these all follow the same pattern. If we go all the way back to a 1 proportion z interval, we had p hat plus or minus z star times the standard deviation. View the difference. You had p hat 1 minus p hat 2 plus or minus z star times the standard error. If you had one sample, you had x bar plus or minus t star times the standard error. All of these are the same. All right, we should be getting used to that. Now, if you are using t star, what do you need? If you're trying to find that, you have to use inverse t, so what are you going to need? You're going to need degrees of freedom. All right? Unfortunately, that formula is a disaster. In fact, the formula looks like this. I know that you don't want to do that. I don't want to do that. That sounds like a whole lot of stuff. It's not anywhere on a formula sheet, so that sounds like a disaster. Okay? And so, because it's a disaster, we don't ask you to use it. That would be rude. Right? So instead, we leave it to the computer or the calculator. In this case, we're going to talk about using your calculator. Okay? So, you're going to get to use your calculator to find t. There's not an easy way to do that besides just constructing the interval on your calculator or completing the test on your calculator. But here's what I'm going to tell you. I've only showed this to you one time we did one proportion because it should not be your crutch on the AP test that you're just going to go through and put some stuff in your calculator and write a bunch of numbers down, because that will get you no credit. You have to write everything out. So it's like I keep telling you to write everything out. When we start reviewing, I might show you some of them so you can start looking at it. Okay, I'm going to check my answer, that kind of thing. Okay? But in general, we need to make sure that we have the right numbers and all of our conditions and all of our statements and everything so that you get full credit on a free response question. Okay? So I'm still going to have you write things out for these confidence intervals. Okay? All right, so here is our standard error equation. Okay? So it walks you through the steps. If you don't like the algebra, that's fine. But we already know that we can only add variances. Okay? So the variance is also the standard deviation squared. So that's the standard deviation for one sample mean. And so we square it to get the variance. And that yields this formula for the standard deviation. But we still don't know sigma. So this is what's on your formula sheet. And then you should know you estimate using S. Okay? We are going to be fine with this confidence interval because it's the same thing we've been doing over and over again. Okay? So remember, one more vocabulary thing. Standard error is an estimate and standard deviation is for the population. Okay? So make sure you know the difference, especially when you ask the multiple choice question. Make sure you know what you're talking about. All right. I think we have enough information that we can go through and we can construct a confidence interval. So one question today, and then I'm going to let you do some stuff to make sure you understand. But a man who moves to a new city sees that there are two routes he could take to work. A neighbor who has lived there a long time tells him Route A will average 5 minutes faster than Route B. The man decides to experiment. Each day he flips a coin to determine which way to go, driving each route 20 days. He finds that Route A takes an average of 40 minutes with standard deviation of 3 minutes, and Route B takes an average of 43 minutes with standard deviation 2 minutes. Histograms of travel times for the routes are roughly symmetric and show no outliers. Nice to know. So in part A, find a 95% confidence interval for the difference in the average commuting time for the two routes. All right, so the first thing we need to do is check the conditions. I am not going to take the time to write all of those out because we've done this enough. I'm going to say them aloud and talk through them, and then we're going to move on. So, first thing, is this a random sample? Is that where he got the data from, a random sample? Yes, because it says somewhere he flips a coin to determine which way to go. So random is good. Now here's where your 10% doesn't make so much sense. Their sample size is 20. So 20 is less than 10% of all days that I could have taken Route A or Route B. That just sounds weird. You can drive that route probably infinitely many times. Okay, so if you don't write it down, it won't be the end of the world. I do want you to keep it in mind, though, because if not, you'll forget about it for proportions. Okay? Okay. Then you have independent groups. So is the data collected independently? Yes, he does. Route A, 20 days randomly, Route B, 20 days randomly. They shouldn't influence each other in any way, shape, or form. Okay? And the last one's nearly normal. It would be nice if we had a picture, but we don't. But it says, histograms of travel times for the routes are roughly symmetric and show no outliers. So we can say that each group has a nearly normal distribution. So conditions are met. All right, so the next thing we do is name the interval. Because the conditions are met, I can use a T model. And I can use a two sample T interval. Perfect. So the formula for that is x bar 1 minus x bar 2. You have to decide if you're going to do route A or B. It doesn't matter. Which one goes first? If you want to make it positive, you would probably put B first. Make it negative, you put A first. Doesn't matter to me. Okay, so do B minus x bar A plus or minus T star, which we're not going to know because we don't have the degrees of freedom, so we can't figure it out. We're just going to keep it there for a little bit. And so our mean for route B, 43 minutes. Our mean for route A, 40 minutes. plus or minus T star times the standard error. So the formula for that is the square root of S squared B over NB and S squared A over NA. So sample sizes are the same in this case. They don't have to be. All right, so that's nice. I've written that out, and that's probably enough and sufficient to show that I know what I'm talking about. At this point, this is where we have to use our calculators, okay? So here's my calculator. You will go to stat test. I have a bunch of intervals and tests in here. We're doing a two sample T interval. So two sample T interval. Now there are two ways you can construct an interval and perform a test here on your calculator. There's the data option. That means you have a list of information and you put it in list 1, and you have another list of information that you put in list 2, and it'll calculate it for you. Then there's the stats option for if you have the mean and standard deviation and sample size, which we do. So your calculator always does a 1 minus 2. So we put B first, so B should be 1. So route B takes an average of 43 minutes. 43, standard deviation of 2 minutes, sample size of 20. And then for route A, 40 minutes, standard deviation of 3, sample size of 20. That's for your confidence level, 95% confident. Then it asks if you want to pool, okay? We'll talk more about this with tests. We didn't pool when we did proportions. We're not going to pool. When we did proportions, we did two proportion Z interval. We're not going to pool when you do a two sample T interval. So right, no pooling. So press calculate. Give it time to think. Then it gives you, right, so it gives you the interval right here. It tells you the degrees of freedom right underneath. Okay, that's their estimate using that big, long, crazy formula. Okay, so I know the interval is from 1.36-ish to 4.64-ish, and the degrees of freedom are approximately 33. Okay? So I had to do my calculator. There was no way otherwise to do it. Now, I have to write a conclusion. That is part of completing a confidence interval. So I am 95% confident. That you can say two ways. That the true average difference in route time is between 1.36 minutes and 4.64 minutes. Units are very important. Or I am 95% confident that the average drive time or route time for route B is 1.36 minutes to 4.64 minutes longer than route A. So you can write either way you want to compare it. Now, I said longer than, right? Well, if route B minus route A is a positive number, that means that B had to be a longer time. Okay, so make sure you're thinking about time. On part B, should the man believe the old-timer's claim that he can save an average of 5 minutes a day by always driving route A? So though route A is shorter, we decided that route B is longer, all right? Can he save 5 minutes? Well, it's 5 minutes in the interval. No. So even though it's longer, that claim doesn't seem to be true. Okay, it seems to be that route A takes 1.36 to 4.64 minutes shorter than route B, so he's not saving 5 minutes, maybe a maximum of 4.5 minutes-ish. We'll see. Okay? We've done this stuff before. Questions? All right.